Question 1. The triangle ABC is shown in the diagram below. The coordinates of B are 3, 0 and the coordinates of C are 9, minus 2. The broken line is the perpendicular bisector of BC. Find the equation of the perpendicular bisector of BC. Okay, so to find the perpendicular bisector, what you need to do is find the midpoint and then find the perpendicular gradient. Then you'll substitute that midpoint into that with that new gradient, and that will give you your final answer. Okay, so let's start off. Question 1. So your midpoint, and that's going to be equal to, write our coordinates 3 and 0, and 9 and minus 2. That's going to be 3 plus 9 over 2 and 0 minus 2 over 2. That's going to be 3 plus 9 is 12, 2 is 6, minus 2 over 2 is minus 1. Okay, so that's our midpoint. Then what we need to do is work out the gradient. So again, we'll go MBC is equal to y2 minus y1, but here I'll just put in x1, y1, x2, y2. So we'll have minus 2 minus 0 all over, x2, which is 9 minus 3, which is equal to minus 2 over 6, which is equal to negative 1/3. And now we need to work out our perpendicular gradient. So perpendicular, well, the relationship between perpendicular gradients, as we should know, is minus 1 times m1 times m2 is negative 1. So this is just going to be the inverse of that and change the sign. So that's just going to be 3. Okay, and now we have a point on the line and we have a gradient, so we can finally put this into our equation of the line. So y minus b equals mx minus a. So y minus 1 is equal to 3 times x minus a, which is 6. And we just multiply this out. So y plus 1 equals 3x minus 3 6s are 18. So y equals 3x. This goes over there, becomes minus 1 minus 19. That's your final answer there. So you get your marks from 1, finding the midpoint, 2, finding the gradient, 3, finding the perpendicular gradient, and 4, for writing out your final expression in the correct form. Part B now. The equation of the line. Part B. The line AB makes an angle of 45 degrees with the positive direction of the x-axis. Find the equation of AB. So this is this line here. So we're saying in here is 45 degrees, and I've sketched it here. This is 45 degrees. Well, the relationship that you should know is m is equal to the tan of the angle, and that gives you the gradient of that line. And tan 45 is 1. Okay, now we have a point, so we can just sub this in. So we have y minus b equals mx minus a. So, and our points A and B come from this point on the line B, okay, because B, or else this should be B even. So you can just substitute these points in. Minus 0 equals 1, x minus 3, so equals y equals x minus 3. And that's the final equation there. And you get 1 mark for knowing this relationship here, and you get 1 mark for writing the correct final expression. Part C. Find the coordinates of the point of intersection of AB and the perpendicular bisector BC, of BC even. So this is just simultaneous equations again, so you need to put down your 2 previous answers, which would be y equals 3x minus 19 and y equals x minus 3. Now, this is quite simple. You can just, because they're both equal to y, you can just put the two equations equal to each other. So that means 3x minus 19 is equal to x minus 3, which is the same as saying 2x is equal to, move that over to the right hand side, that becomes positive 19, that equals 16, and that means x equals 8. And you just need to put this value of x back into one of the equations, which is the simplest one. Y equals 8 minus 3 is equal to 5, so the point of intersection is 8, 5. Therefore, point of intersection is equal to 8, 5. That's your final answer there. And you get 1 mark for finding the x coordinate here, then you get the next mark for finding the y coordinate there.